Now let's start collecting the antiderivatives of some of the common functions. So we're just going to make a table here. We remarked last time that the constant function, a, has an antiderivative of ax plus c. What about the power function, x to the n? Well, let me just write something down and then convince you that it's right. So I'm going to write 1 over n plus 1 times x to the n plus 1. So how do I know that this really is the antiderivative of x to the n? Well, I take the derivative of the thing on the right-hand side, and I'd better get the thing on the left-hand side. The derivative of x to the n plus 1 would be n plus 1 times x to the n. And so the extra factor of n plus 1 would cancel out this extra factor of 1 over n plus 1. There's a restriction here, though. This only works for n values other than -1. Because if I had n equals -1, well, this would tell me I'd get 1 over 0 times x to the 0. Clearly, that's ridiculous. So what's the antiderivative of x to the -1, or in other words, 1 over x? Well, it's the natural log of x. Actually, to be really sort of picky about it, it's natural log of the absolute value of x. This is just because natural logs are only defined for positive values, whereas 1 over x is defined for positive and negative. And this is a little bit trickier to take the derivative of, but the derivative of ln of absolute value of x really is 1 over x. Okay, we saw last time that the antiderivative of cosine of x was sine of x. And it turns out that the antiderivative of sine of x is negative cosine of x. Notice that the minus sign goes with a different formula this time. The derivative of sine was positive cosine, but the antiderivative of sine is negative cosine. We have that the antiderivative of e to the x is e to the x plus c. Well, what about more generally? What if you have something like 2 to the x or 10 to the x? What's the antiderivative of that? Well, it's going to be very similar. It's going to be a to the x divided by the natural log of a, and then plus c. This is because the derivative of a to the x multiplies by an extra factor of ln of a, and so the antiderivative has to kind of undo that. Okay, this gets us a lot of sort of basic building blocks. So what we would like to know now is how you can start putting those pieces together. So for example, let's say you wanted the antiderivative of f plus g. Well, again, I'm going to just make a claim and then justify it. The claim is that I can just take an antiderivative of f and then an antiderivative of g and then add those up. And essentially, this kind of linearity occurs because it happens for derivatives. So maybe let me just do an example to convince you that it works for kind of a random case here. Like, let's say you want the antiderivative of x cubed plus sine of x. And so the claim is you just do it one term at a time. So for x cubed, that's this general form x to the n. So what I do is I increase the power by 1 and then divide by that new power. And then the antiderivative of sine is negative cosine. We just put a single plus c at the end. I don't bother to put two different plus c's here. So the claim is that this is an antiderivative of x cubed plus sine of x. Well, certainly the derivative of what I wrote on the right-hand side splits up over that subtraction here, and so it gives me those two terms, x cubed plus sine of x. Okay, it's also the case in general that if you want the antiderivative of some constant times a function, that the constant just pulls to the outside. Again, just like derivatives. So for example, if you wanted the antiderivative of, say, 5x to the 7th, well, that's just 5 times the antiderivative of x to the 7th. So 5x to the 8th over 8. Now let me look at one more complicated example just to show some of the things we don't yet know how to do. What about the antiderivative of x plus 3 times x minus 1? Well, I shouldn't expect that I can just take the antiderivative of those two pieces and multiply them together. Remember that with derivatives, for example, that didn't work. The derivative of a product of things required use of the product rule. And at the moment, I don't have a rule for this, and indeed, we're not going to get a rule for this. So what I'm going to do in this case, actually, is just do some algebra first. We're going to just rewrite the inside. So we're going to sort of multiply that out. So the inside is just x squared plus 2x minus 3. And well, now that's something I know how to deal with. We get x cubed over 3 plus x squared minus 3x plus c. So this was really our only choice. We only know how to deal with functions that either are themselves very simple or that are the sum or difference of some very simple functions. And for now, that's sort of all that we're going to be able to do.